All right, folks, so the lesson today is on the normal approximation of a binomial distribution. This will not be on the quiz, so you don't have to worry about this being on the Wednesday's quiz, but it will be on your final exam. So let's take a look at it. So what we're doing here is we're using a normal distribution to approximate a binomial. So we've done the binomial distribution already. And if you look here, that was using this calculator right here where we have an NP. And binomial distributions are discrete, so we're dealing with whole numbers for x's, right? So what we can do is we can use a normal distribution to approximate a binomial if these two rules happen. If your n times your p is greater than or equal to 5, and your n times 1 minus p is greater than or equal to 5. So if both of these are true, then you can do the binomial approximation of the normal distribution to approximate a binomial. Your mean is going to be n times p. Your standard deviation is going to be the square root of n times p times q. Okay, that's how you get the mean and the standard deviation. You do have to apply what's known as a continuity correction factor. And what that means is that for the continuity correction factor is if you're looking for exactly 6, you want to find between 5.5 and 6.5. If it's x is greater than 6, then you want to do x is greater than 6.5. If it's x is less than or equal to 6, then you want to do x is less than 6.5. If it's x is less than 6, then you want to do x is less than 5.5. If it's x greater than or equal to 6, then you want to do x is greater than 5.5. That's known as a continuity correction factor when you're using a normal distribution to approximate a binomial. So let's take a look at a problem here. It says a factory produces light bulbs with a defect rate of 5%. So n is going to be 200. P is going to be 0.05. So let's go ahead here. And this, what is the probability that fewer than 8 bulbs are defective? So we want x is less than 8. And by the way, that's the same thing as the probability that x is less than or equal to 7, right? Because remember that this is discrete. So when it says less than 8, that means that we want to find the probability that x equals 0, 1, 2, all the way to 7, right? So that's going to be what this one is here. So we can go to our binomial calculator, and this is doing what we've already done. So n is 200, p is 0.05, x is less than 8, but we have to go to 7 here because it's less than or equal to, and then we have it, and that's going to be 0.2133. So 0.2133. So that's doing it the way we've already learned to do it. Now, if we use a normal approximation of it, okay, you should get around the same answer. So first of all, we have to verify that n times p is greater than or equal to 5, and then n times 1 minus p is greater than or equal to 5. So let's verify that. So we have 200 times 0.05. That is equal to 10. So that's greater than or equal to 5. So that works. And then here we have 200 times 0.95, which is equal to 190, which is greater than or equal to 5. So that works. So we're good. We can use the normal approximation to find the binomial. So the mean is n times p, which we've already calculated here to be 10. The standard deviation is the square root of 1 times p, which is it's n. Talking too fast, and so standard deviation is going to be equal to n times p times q. Now q, if you're wondering what that is, that's just 1 minus p. So q is just equal to 1 minus p. So in this case, that's going to be the square root of 200 times 0.05 times 0.95. And we can calculate that out. (9.5), but then we have to take the square root, we get 3.1. So now we have the mean is 10, and the square root is 3.1. Now in this case, we're looking for the probability that's fewer than 8. So the probability that x is less than, using the continuity correction factor, it's going to be 7.5. right? Because once again, if we're looking for less than a number, we have to subtract a half from it. So using the continuity correction factor, it's going to be less than 7.5. Now drawing the bell curve of that, got to write really small here. That's going to be down here somewhere. So let's go ahead and let's find that probability. Got to go to the normal distribution. Click on it. Mean is 10. Standard deviation is 3.1. The number is 7.5. We want to find the probability that's less than that. That's going to be 0.21. So you can see that it does work out pretty accurately when we do that. So we'll do one more example. A survey shows that 30% of a town's residents support a new policy. If a random sample of 100 residents is chosen, what is the probability that at least 35 people support the policy? So in this case, let's check to see that n times p is greater than or equal to 5, and that n times 1 minus p is greater than or equal to 5. So n is 100 times p is 0.3. That's 30. So that checks out. N is 100 times 1 minus p is 0.7. That's 70. So that checks out. So we're good. So let's do our mean, which is n times p, which we've already done to be 100 times 0.3, right? Because n is 100, p is 0.3. So n times p is 100 times 0.3, which is 30. And standard deviation is equal to the square root of n times p times q, which is the square root of 100 times 0.3 times 0.7. So these two numbers will always add up to 1 in the formula. So it's going to be 100 times 0.3 times 0.7, which is 21. And then you take the square root of that, you get 4.6. We're actually doing part B right now. I'm sorry. We're using the normal approximation. So the mean is going to be 30 and the standard deviation is 4.6. I'm going to actually erase this here. So part A, we just do the regular normal distribution, or the regular binomial distribution, I'm sorry, the binomial. So n is equal to 100, p is equal to 0.3, x in this case is 35. So it says, what is the probability that at least 35 people support the policy? So the probability that x is greater than or equal to 35. So if we go to the binomial calculator, n is 100, p is 0.3, and we want x to be 35. And it says at least, so that's greater than or equal to. So 0.16. Now using the normal approximation, okay? So at least 35, so that would be here. But we got to apply the continuity correction factor. So if it's greater than or equal to 35, what would that be with the continuity correction factor? That would be this one. You have to subtract 0.5 from it. So we would have to do 34.5. So probability that x is greater than or equal to 34.5. All right, so mean of 30, standard deviation of 4.6. And we get 0.16. So once again, you can see it is pretty accurate. Hope that helps. Go ahead and work on the practice problems that I provided, and I'll take any questions on class on Wednesday. Have a great rest of the couple days here.